Hey guys, Ted here again. Sorry, I have a problem with my jaw today, so I won't be talking as much. But you can watch me right on here, and I would still give commentary and stuff. I just got done watching Michael Moore's Planet of the Humans. It was suggested by a buddy of mine, which I agree with most of it. But the only problem that I disagree with is they are not telling you exactly the problem. The problem is, yeah, bioenergy is bad, but why is it bad? It's burning carbon. Just like other fossil fuels. Which they didn't want to admit that, but at least not from what I understood of it. They said in one part that yeah, it's the same. They can't use it without using regular fossil fuels, but they did not demonize fossil fuels. See, they're trying to show this hand and hide this hand. So what I'm gonna illustrate on here and give a couple tidbits of commentary for is the renewable energies that we can use, okay, and the ones that yeah we still need to burn the fossil fuels and energy because we can't just go from in like 1 year from this grid to that grid. But you will see what I mean, okay? Alright. Okay. So here we go. Again, I apologize for my crude drawing ability. The Earth. Oh, it's not up to scale. I know it is. The moon. You know, all the space and stuff like that. And we actually, us and the moon rotate around the sun, which I will have the sun right here. Why is it there? Because the sun's moving. Because we revolve around the sun. Not a perfect circle, lunar, like an oval almost. Okay, that's what gives us different seasons. Okay, I wouldn't just represent that by. Well, I'm not going to the sun, but you know what I mean. Okay. So why is that important to illustrate that? It's not gonna be sunny all the time. Okay, now we have solar energy, like shout out to my peeps in Australia. Okay, we have hydro. Hydro, like water and stuff. You get what I mean. And then we have wind energy. I'm not gonna add biomass in here because, like I said, it's the same thing. It's just taking carbon from the ground and burning it, or taking carbon that's living and burning it. And I'm gonna also add geothermic. Put go Pokemon. Geothermic. Geotherm because I don't have that much space. Geothermic, and the one that a lot of people don't like to talk about, nuclear. But I like to remember it as nuclear. Okay. And mechanical. And now you might say, well, the wind turbine or the hydro relies on mechanical. Yeah, but I mean mechanical that's not a perpetual motion. We can't do that, okay? But we can come close with magnetic, fields and stuff like that. Okay, then we maybe just put magnetic. Okay. I was gonna put mechanical. Okay, I would put mechanical because they're both the same thing. Well, not both the same thing, but for what I'm talking about, for this sake it is. Okay, now, let's say, since it's not always sunny, the dams the water does not always push through fast enough for the dams, and we don't have access to a lot of dams. The wind's not always blowing. The geothermic, the pressure underneath from like the volcanoes are always bubbling up. But later, I still add the mechanical in there because we're gonna use, and you will see. Okay, and nuclear. Okay, which yes, I know it's dangerous if it gets overheated. Those poor Japanese and Russian people. I'm sure it happened with other people, but that's only two I can. Fukushima and help me out here. Why do I remember Fukushima? I don't remember Chernobyl. Sorry about that. I live in Japan right now, so not Japan, but that one's more Japan than this Chinese. Okay, so anyway, as my phone exhibits why we can't just use batteries, okay, because they run out too easy. Okay, but we can still use for magnetic energy, and most of this we can use batteries. Okay, so let me add batteries up here. Now, all of this that will take manufacturing, which will involve, burning carbon and stuff. But once the carbon's burned from fossil fuels, do we get it back? No, we don't. Now, these will take, much more than simply burning. Some people might say, you will get more energy just simply burning. But guess what? Can't reuse that. You have to go get more to reuse that. Like, say, natural gas or, let's just say ethanol. Okay, let's say ethanol versus solar. Okay, now it would take ethanol to get the solar. Okay, but now it's gonna say, let's say it takes 100 million units of whatever the unit might be. Okay, let's just say whatever that unit might be. I don't know what it is. But let's say it takes 100 million units to get the solar power up. And it only produces 20% of what the fuel could be used for ethanol, pure ethanol. Well, okay, but once the ethanol is gone, you have to go and get another 100 million, right? Now, for solar power, you can just keep reusing it. Yeah, it would take, since the solar is already there, maintenance to that even if it just takes half that, even if it takes half of it, which, no, unless somebody breaks it or something on purpose, okay, just annually renew, stuff like that. And you can use solar power, whatever solar power is, to help with your, say you use 10% of the solar power that was created to renew it, okay? And that is equivalent to 100,000. Oh, I'm sorry, 2 million. Up. 2 million. Okay? Now you only need 50 million, so that's 49. That's still gonna be a bit, but every year. So after, let's see, what is that? That's 49. 24.5. So after 5 years, that 20%, the efficiency will go up to about 50. Oh, not 50, I'm sorry. I was adding that wrong. About 30, what's that? 34.6. Okay. And this, okay, and then the renew would just take, okay, let's say it still takes half of it. Let's give them that. Okay, give who? I don't know. Okay, but, okay. So, there, after 5 to 10 years, it can be self-sufficient and it's able to fix itself on the solar. Okay, and after that, after the halfway mark of that, 2.5 years or 5 years, it won't even need new ethanol. You can just use the percent, as you see. Beyond 15%, it can be renewed by itself. Yeah, but anyway. I like maths, so, okay, let me erase this, and you guys, if you want pause to check my math, go for it, but I'm pretty good, so, I'm not the best, I'm not a scholar, per se, okay, but anyway, and 2 point, what would that be? That would be 2.33. Yeah, it can get saved. That's stuff that can get saved in the batteries. Now you might say, oh, the batteries need maintenance too. Well, just take half of that. Maintenance every year. Okay, before the problem gets really bad. Okay, so if the solar, say, after 10 years, 3 of these are okay, and then even though 2 of them don't work, then we have 3 more to count on, okay? See, you base like that what? If there's no light, okay, if there's no solar, we can count on the wind. If there's no wind or solar, we can count on the hydro. Plus the geothermic and nuclear. And the mechanic magnetic. Okay. And what I'm going to use, I don't know why I'm doing this here. I just want to draw. Okay. Anyway, what I was talking about, how it becomes mechanical, is nuclear. The only problem with that is the core gets very, very hot, and it's radioactive. So yeah. Well, we can go ahead and there's coolant chambers that they already have. What they do, they flood it before it gets to a certain temperature. Oh, that turns the heat. Okay? And if we get a liner, okay, like say a lead liner, okay, above the core and stuff like that, it will actually turn into like a stove. Yes, a stove gets hot, but with that comes geothermic heating. Okay, geothermic's from the earth, right? So we basically make mechanical geothermic. Geothermic, I told you mine. Yeah. I got a canker sore. It hurts like a son of a gun. But this wasn't important, so. Okay, so nuclear and geothermic can help each other. Okay, but like I said, nuclear is very touchy, so we need a lot of maintenance. So it's gonna take about 20 or so years. Or these other ones are slowly moving up. This is one's gonna move up slower. Okay, but it's still very possible. So when this moves up, at a pace of like, what did I say, 2.33? Yeah, 2.33 per every couple of years, every 2.5 years, something like that. We can use this like every point. What's that? Every 73.25. So every 0.73. That doesn't sound like much. That's why I'm saying 20 years. But the geothermic is it relies on it, but we have geothermic from the core in our planet anyway, and pressure. All we need to do is make pressure. Like fracking. Why fracking is not real good is because of the chemicals they put into the ground to get the oil and stuff up. But what if we just put in like water, like normal water, no chemicals, nothing like that, just stuff that would be natural, okay? Just put in that to make pressure. But we have to be careful of the fault lines and stuff over. So that's touchy itself. So it's better to let those be steady. Okay, and it turns into mechanical because we actually unofficially make it. And we can use magnets. Okay, I've actually done a little project by myself. And I've made a joke. Well, not a joke. Not a joule. Yeah, it wasn't a full joule. It was about 0.4. 0.4 is about 8, but not 0.8. 0.8, not 8. 0.8. It's not even a full volt, but still, it's not too bad. Okay. So we can use those since we're using wind anyway. Okay. Now since we're using the wind and the hydro anyway, we can put magnets also on the turbines. Okay, so we can make some other, energy. Okay, and with solar is pretty much the only one that's by itself. Okay. I haven't figured out a way to do that. We could use artificial light, but that's taking the same more energy to produce the artificial light. Okay, and since there's still gonna need factories to burn stuff like that, I was thinking of acidity. Sorry. In the batteries, okay, and what's happening to the oceans now for marine life? What we did to ourselves, what can we do? But we can fix it, guys. Okay, so my thing is either at the top, which I don't see how that would be feasible. So maybe inside line it with a water system. Okay, a water filtration system. Okay, so here, this is a crude design, okay, of the smoke going up a pipe. And there is, okay, there's water, the pipe will, say, go up to the top, and there's water that's not directly in the pipe, make it so the water can't really go in the pipe. Okay, what you can do there is you can make it fasten at the top or something like that. So just the smoke will plume out of it, and then what that will do is that will make the water acidic, just like the poor oceans. Okay, and then we can use that for batteries. Yeah. So thank you to my friend, and thank you, Michael Moore. Your video was very illuminating, and your friend Jeff Gibbs. Yes, thank you very much. Okay? Alright, guys. That's my rambling. I need to go put more canker story medicine on. But just petroleum.